We're going to get this show on the road. This is the capstone experience for CCI, and I have to say, having been at Drexel since my freshman year 31 years ago, this has come a really long way. When I was a senior, we didn't have anything like this. It evolved in 2004, 2005. The CS department started doing kind of a formal senior design project. The former high school, I think, started earlier than that. And then last year, we merged the two into one giant contest. And what we've really seen is an increase in the quality of the projects, not just because we have more students, but because we have a greater diversity of students working together. And we really want to see not just kind of straight CCI projects, but a lot of interdisciplinary projects grow as the years go on. I was one of 3 professors that coordinated and advised the immediate classes of senior project. There were actually a lot more professors involved because each group had a domain expert, so sometimes that was a faculty member, and other times it was an external stakeholder, and sometimes it was both. And for all the freshmen that are in the audience, there's quite a few of you here, this is a really good time for you to see what makes a good senior project. And I encourage freshmen to start thinking about it now. You can do a number of things. You can start your project ahead of time and just keep building on it. I encourage you guys to be entrepreneurial, so some of these projects have kind of a natural business model that they can follow. The problem is, if you wait till your senior year to get started, sometimes you don't get enough done by the end of the senior project to be ready to roll, and then you have the pressure of student loans and other realities kind of crashing down on you. So the earlier you can start, the better, and some of our projects actually did. One of the things that we do with senior projects is we have external judges come from industry. So Drexel's always had kind of a foot in the industrial world, the co-op and things like that. It's one of the things that makes us special. And so senior project is no different. So we have a number of companies represented, Bentley Systems, Cigna, eMoney, and Unisys, all who have supported senior projects into a senior design for many, many years. The judges that we have here tonight are Josh Daltrey from eMoney, Colin Kerr and Erlen Lutz from Bentley Systems, Brian Mitchell from Cigna, and, wow, I need my reading glasses, Rick Weiler from Unisys. The other professors, if Professor Vokolos and Vokolos will stand up, who are around to help me. I have to say, for the 3 of us, I felt at the end of this year, this was such a rewarding year as a professor. One professor once asked me, why are you at the university? And this is one of those reasons, because for myself, I get to work on projects I would never get to work on in corporate America. And it's not to say that corporate America is bad, but everyone comes to life with certain goals, and you guys help me reach mine as you guys reach your own. So with that said, we're going to go to the first of 4 presentations. JamJar, you want to come on up?
Hello everyone, I'm Banin.
I'm Drexel.
I'm Marco.
I'm Sanjana.
And I'm Riback. And we are Team JamJar. When you attend a concert, there's no doubt that you'll see a lot of people around you having phones above their heads, taking videos. Look at this photo, for instance. In this photo, we count 14 phones. Now, that's a lot of video here, right? But what happens to these videos after the concert ends? Generally, they're very short and insignificant without more context. This is why we built JamJar.
So, what is JamJar? It's a web and mobile application that takes concert videos that users have uploaded and automatically synchronizes them based on where their audio overlaps. The app makes it possible to replay concerts from different perspectives. So here's a little preview of what this will look like. You guys will see this later in the demo.
So now we're going to talk about the core underlying technology that drives JamJar and makes it possible for JamJar to automatically determine where videos overlap with each other in time. This is a technology called audio fingerprinting. Here we have two human fingerprints. And although there are some minor differences between the prints, you can tell from the overall structure that they are in fact likely from the same person. Audio, similar to human fingerprints, contains a lot of data and features that we can use to determine when videos overlap with each other in time. Over the course of a concert video, the music contains patterns of pitches and frequencies that we can use to create what's called an audio fingerprint. When we find two videos that have enough matching audio fingerprints, we can say with a fair amount of confidence that they are in fact videos of the same event. The more fingerprints we have, the more confident we can be they are in fact overlapping. Furthermore, we can use these fingerprints to determine exactly where these videos overlap with each other in time and where one starts with respect to another. This image here contains the audio tracks from two videos that we use audio fingerprinting to automatically align.
Audio fingerprinting makes it possible for JamJar to determine which videos in the system overlap with each other. These sequences of overlapping videos are called JamJars. In this example, these two JamJars are separated by a gap between the end of video B and the start of video C. We can see that when the fifth video is added, it merges the whole chain of videos. In this way, you can rewatch the whole concert from 5 different perspectives.
So 9 months ago, we spec'd out a variety of features for JamJar to use, and today we would like to show you those features. So through the applications, you're able to create your own account and log into that account. You can also reset the password. Once you log in, you'll be introduced to the Discover page, where you'll be able to see different JamJar collections recommended by us, as well as see trending concerts, and you'll be able to filter those by genres. So when you go to a concert page, you'll be presented with the information about the concert, as well as all the videos that have been uploaded to that concert, and the JamJars that were able to be created through those uploaded videos. You can also go and a user can go and check out their own profile page, and they can see what videos they have already uploaded and the concerts that they have contributed to. And of course, we implemented search functionality, so users will be able to see the exact content that they are looking for. I'd like to hand it over to Jess to talk about the UI features related to video.
So here's the upload page. All the videos belong to a concert, so we ask users to provide the artist, the date, and the concert venue, and then you can upload from here. And this is the video playback on iOS. We allow to use all the normal video buttons, so play, pause, and see. We also allow users to like or dislike a video, and users can flag inappropriate content or low quality content. And this is the web player. So again, JamJar is a collection of overlapping videos that were stitched together. So here we have the web and iOS screens of the JamJar player, and both have overlays. So on the web, we represent the JamJar as a timeline. So it shows all of the available videos that you can click on when they turn green, and it'll switch to those videos seamlessly. And same for iOS, except all of the thumbnails represent the videos that we can switch to.
So now, JamJar is a pretty complex system, so we developed an environment to develop it on. First of all, we used a stack called the MAD stack, which involves using MySQL as a database, Apache as our HTTP server, AngularJS as our client-side web framework, and Django, which is built on Python, as our RESTful API framework. To develop the platform, we used Python, HTML, and CSS, as well as JavaScript on the client applications, and Swift in the iOS application. These distribution graphs come from GitHub and tell you what amount of code is used in each repository. JamJar has a lot of different dependencies, and installing these dependencies manually every time we wanted to build up a new server would be very error prone. So we use Vagrant and Chef as dependency tools to automatically install these things for us. Gulp we used as a build tool for our client-side application, We use GitHub to foster collaboration between different developers, and we use Travis CI as our continuous integration test suite. We also built the entire production system on Amazon Web Services using EC2, S3, RDS, and notably Elasticache and Route 53. We'll talk a little bit more about these soon, and you'll see exactly how each part is used.
Great. So now we're going to talk about the system architecture of the JamJar application. And I think a great way to do this is to trace through typical requests that come into the API. So any request immediately hits the Apache HTTP server after being sent by a client. From here, this is an EC2 micro instance. So from here, a general request will hit the web API server, which is Django, and further, usually this request hit the database, or an RDS instance. At this point, the request is routed back to the client. Another type of common request is upload requests. In this scenario, Apache routes the request to the transcoding server below. From here, an asynchronous job is added to our async job queue, managed by Redis. When the transcoding server workers are free, they pop jobs off the queue and execute the tasks in the task runner. The task runner includes transcoding the video for playback on mobile and web to two different formats, as well as audio fingerprinting the audio from the associated video, and storing this information in our fingerprint database, and finally, uploading the video to our cloud video storage service, Amazon S3. Lastly, when clients want to stream video, they're requested directly over HTTP from the cloud video storage service, S3. So we built JamJar with this architecture to provide the scalability, both vertical and horizontal. So for us, vertical scalability means changing the instance type in AWS. So for instance, we can ramp up these web API servers from micro instances to more powerful servers. Horizontal scaling is accomplished by adding more servers, and this is managed by Apache with mod proxy.
So when developing JamJar, we had a lot of design decisions to make, some which were really hard and some which were not so difficult. But we're going to highlight some of the more difficult ones. So this is a entity relationship diagram of JamJar. And you can see the color coding of the four most prominent components in the application. So on the left, in blue, you can see the users. On the right, in orange, you can see our videos. Down in the lower left, you can see, in green, you can see the concerts. And in the lower right, you can see our artists. In between these components, you can see gray areas which connect them as relationships. So from this, you can determine that users upload videos which are part of concerts and contain many artists. Down here, you can see that we actually also connect concerts to artists. We decided to denormalize our database in order to make it more efficient to determine which artists were actually related to a concert. One of the earliest design decisions that we needed to make with JamJar was how do we actually represent these sets of overlapping videos? We came to the conclusion that using a directed acyclic graph was the most appropriate data structure. First and foremost, the data lends itself really nicely to such a structure. Our videos are the nodes, the overlapping relationships between videos are the edges in the graph, and the temporal offsets, that is, when one video starts with respect to another, are the weights between videos. We also contain confidence levels in the edges between videos. One of the major reasons that we use this data structure to represent our JamJars is because it allows us to easily merge graphs. That means when new videos come into play in the system that combine two previously disparate graphs, it takes a constant time operation to merge these sets together. It also allows us to represent a dynamic timeline. That is, when we get new videos that start before all of the other videos in a set, we can take one operation to place this in the beginning without having to push all the other videos back and do a lot of recalculation. When building the system, we also kept in mind best practices as well as design patterns and principles that we learned here at Drexel and on our co-ops. We use a service-oriented architecture to manage the communications between our client applications and our RESTful API, as well as external third-party APIs. We use the single source of truth principle to leverage Google Maps and Spotify. We know they're a lot better at searching for locations and artists than we are, so we let them do what they do best, and we leverage their unique identifiers in our database. We use a facade pattern over our fingerprinting library, so that should we decide to change the library down the road, we could easily swap it out for another one. And we used authentication decorators to easily and quickly add more security to a given. So an important design decision that we made early on was to represent concerts as a unique pair between a venue and a date. This simple model accounts for a random house show in your friend's basement or a large-scale weekend music festival. We then associate the artist with the videos to account for a concert where there'll be multiple artists playing.
So now that we've given you a little bit of an overview of the application, the tools that we use, the design, and the approach, I'm sure you're wondering how we did this in 9 months. So first we use a tool called Slack for team communication. As you can see with the conversation here, there are channels that can filter for conversations. And we use this not only for instant messaging and also sharing files, but also to facilitate discussion and collaboration. Next, and most importantly, we use Trello for our task management. The lists here represent different categories within the project. Each card represents a task, and those can have checklists or subtasks. Cards can be assigned to different team members, and there are also labels that can be used to demonstrate the progress in the project. Here are some stats regarding our uses of GitHub. Pull requests would correspond to feature branches or bug fixes. And the representation here shows the development of the 3 different repositories. On the left, you can see that the development of the API preceded that of the client applications.
So one of the phrases that we often said when working on JamJar was make it work, make it fast, make it pretty, in that order. So to that point, after the features that we wanted to implement were complete, we took a look at optimizing some of these more important endpoints. We did so using a profile called Django Silk. So we used an iterative approach to take down the number of queries run in some of these more popular endpoints from a naive implementation with up to 2,500 queries down to less than 1,000. So it's still a little naive, but it happens to work for the scale that we're running at currently. And the other endpoints we optimized pretty well. So one of the reasons we can make these optimizations confidently is because we test our application. So we use Travis CI, a continuous integration tool, to test every single pull request and branch created in GitHub. This also generated code coverage reports, and further we use black and white box testing to gain confidence in the correctness of our application.
So for web and mobile, we also wrote up test cases based off of our requirement specs. And we would run through all of these before we deploy any other changes. We also wrote up automated unit tests for our API. We also did some user testing. So basically, we'll hand off the application to the users. Then we'll just watch them, see how they navigate through the website or app, write down the feedback or any difficulties they might have with the application. And we took that really seriously when we designed our JamJar player. So now I'll walk you through our Project JamJar site. So this is our landing page. You can sign up, but since we have an account already, we'll sign up as Drew. So we're taken to the main dashboard page. I just wanted to note that this is made with Angular material, so this site is completely responsive. So up here you have JamPage, which is a collection of JamJars that we thought were pretty cool. Here's a collection of concerts containing a lot of videos that you can go into later. And down here, you can also look for videos based off of genre. So now let's go to the profile page. So Drew contributed a lot of videos to JamJar, so we see a whole bunch of videos here. You can click on it and see it. He also contributed a lot of concerts, so you can see like the collection of concerts that he uploaded videos for. So let's go to upload page. So here, let's walk through uploading a video. We're gonna see the Beatles. So let's add as the artist, and this is making a call to Spotify API to see all the artists today, and Beatles are at visit today. Cool, and we'll just upload that. Change the name and let JamJar. Okay.
Thanks.
So now we'll search for an existing concert. So we'll look for Drake, and you see one of the first results is a concert instance. So Drake performed at Coachella, so let's go check out that concert. So here you see a list of all the videos uploaded for Drake, and all these videos actually match at some point. So it created a JamJar up there with 7 videos. So let's go into that. So let's pause. So this is our main JamJar player. You see all the red buttons down here, but all the way to the right, you see a JamJar button. Right now it's set to auto, meaning if you move your mouse, this overlay would toggle on and off. So let's put it to on so we can put it on there. Cool. So this represents the timeline of JamJar. Up there you see a red bar, meaning that's the current video we're playing. All these others are gray, meaning we're not at that point of time in the timeline to click on them. This bar right here shows where we are in the timeline. So as it moves over, it'll turn those bars green, meaning you can click on them and then switch to them seamlessly. So I'll let Drew do it and play the video, but I want you to keep an eye out for the color. So right now that is green and others will turn green, but they will turn red, meaning Drew clicked on them. So we switched the videos to a different perspective. And you can see how we have videos from up close to far away. So as we're reaching the end of this red JamJar, this red bar, that video will finish and it will automatically switch to another video in the sequence. So let's watch that.
I tell Joe, bring 'em. We about to get. I'm gonna roll for some.
So now hand it off to Ethan to go over some of the features for iOS.
Thank you, Jess. So here is what our iOS application looks like, and this is the login screen. We're going to log in using one of our own accounts. Once you log in, you'll be introduced to the Discover page, similar to the website, where you'll have the ability to select jam picks, meaning JamJars that we recommend to you. You'll also be able to see all the trending concerts as well, and filter all of that material by genre. So on the mobile application, we're also able to upload videos in the same way that you can in the web application. You fill out the provided information. And also, you'll be able to search through the mobile application for content in the same way that the web application can. So let's search for content by the artist Selena Gomez. So as you see, as we type, it'll start to return search results for us. So let's check out that concert. When you go to a concert page, you'll be presented with the concert information, all the videos for that concert, and the JamJars that were able to be stitched together. We have 5 videos for this concert, and conveniently all of them are in one JamJar. So let's check it out. Once we get sound going, you'll be able to. So right now, you essentially see a pretty typical video player with pause play functionality and a seeking bar as well. As the video plays out, you'll begin to see thumbnail images appear on the top of the screen. This shows videos that are currently overlapping with the video that's actually playing right now. And if we click on one of those, we'll be able to switch to that video as well, and we'll find the current time as well, helping recreate the concert experience through seamless video transition in the same way that the web application can. There's a lot more that the web application has to offer as well, and is functionally complete, and we hope that after this you can check it out. So now we're going to go over a couple of technical challenges that we had during the development of JamJar.
One of the really challenging parts of building JamJar was working with videos. So of course users can upload videos in whichever format they see fit. We needed to pick 2 formats for playback on web and iOS. These formats are MP4 and HLS, respectively. So we also needed to balance video quality with file size. So we wanted good quality video to make the experience enjoyable, But we also buffer multiple videos at a time, so we want to keep file sizes small. Lastly, we need to maintain the audio quality for the initial transcoding so that we didn't mess with the fingerprinting process. Finally, we use audio fingerprinting in a pretty novel way. It's generally used for audio identification. We use it for both identification and determining the offset between two overlapping videos.
So on the front end side, one of the biggest challenges we faced was designing a JamJar player that was intuitive for the user, because that overlay it's not a standard approach to videos. So we just wanted to make sure that the user really understood what they have to do. We also have to take into consideration the web and mobile constraints. So we have a smaller real estate for mobile and also smaller processing power. So we have to take that into consideration and make sure we created a JamJar player that was fit for both devices. We also have to balance between performance and UI. Since we're doing multi-video buffering, we have to compress the videos enough so that they load fast, but we don't want to compress it enough that it downgrades the video quality.
So one of the big things that we also have to consider are strict guidelines set forth by Apple when we were uploading to the App Store. This actually set forth two requirements that we hadn't considered, where users had to actually sign an end-user license agreement when creating their account, and users need the ability to block other users and their content.
So from a product standpoint, there are a couple other competitors out in the field. We have YouTube, which everyone knows, and they have a lot of concert videos on YouTube. However, YouTube doesn't offer multi-perspective video playback, and it's very difficult to find concert videos for a specific concert on YouTube. Fan Footage is probably our most direct competitor. They offer a very similar service. However, they take a very different approach. While they offer multi-perspective playback, they charge artists to make a music video for artists based on the concert videos that people have taken from the crowd. JamJar hits all these points, and best of all, it's free.
All right, so future work. Over the course of developing this project for the last 9 months, we definitely considered making it a product. So concerts and music are part of a multi-billion-dollar industry, but live music is the only part of that that's growing. So we think that our product can appeal to users, artists, venues alike. So we hope to collaborate with them in the future. We also recognize that JamJar can be used for other things besides concerts, so even sporting events or events where there's public speaking. As Jess mentioned, we did some testing with users, and based on their feedback, we were able to redesign the interface. So we hope to do that more. Also, as we put this out on the market, there are definitely additional legal concerns that we'll need to investigate. And currently, the app is only available on iOS. So we may consider developing it for Android as well.
In conclusion, we can see that JamJar is a creative solution to a complex problem. The application is available on 2 platforms, works effectively, features a unique design, and we're great. So yeah, our application works, which is super impressive, and we built it from nothing in the past 9 months. So we're all really proud of the work that we did, but we'd be remiss not to note our 2 great advisors, Dr. Filippos Vokolos and Dr. Youngmoo Kim, who's somewhere. And we definitely could not have done this without them. So at this point, if you have any questions, we'd be happy to field them.
I'm going to limit the questions to the judges. So I want you to
Go back to the DAG page, please. You specifically force the relationship overlap, which sounds symmetric to me. What makes it correct?
Right. So we only store the forward edges in the database. So for instance, an edge between a video and another video is only right. It's forward. So if you're time x in one video, it's time less than x in the
Start time?
video. Yeah, start.
Start, okay.
Sure, and that's how we start. We start as the relative offset from the start, first video to the second. A lot of algorithms become much easier or even just possible to do if it's directed. For instance, we use topological sort to figure out the first video in the graph. We also do a lot of work to find all of the connected nodes, to identify the JamJar that video is. So for instance, some other videos might be a part of this concert, but if they're not connected in this graph, then we exclude them from the video.
So regarding the technical implementation, so if you do it all over again, what would you do differently?
It's a great question. I think it's two-sided. From a product point of view, I think there's a lot that we could do to make it more readily marketable and usable. For instance, like search engine optimization.
That's not technology.
Yeah, sure, but it's really important because we want to take off. We did all this work for a reason.
Right.
I think things like that are important. But from a technical perspective, geez, Mark, what do you think?
I think there's a lot of things we could do differently from a technical side. The videos are not always the best quality, so placing more restrictions on what types of videos can be uploaded, whether it's vertical or
How
horizontal.
about the stack?
The stack?
Yeah, we tacked on scalability after the fact in practice. We knew we wanted to include it, but at the outset, we didn't really know what that meant. So I think we made it work with Apache, Nazi, things like that. But certain aspects of the actual uploading process need to be, or can't be concurrent. So we'd have to lock. And of course, you'd upload to different concerts at the same time, but you can't upload to the same concert. That's a concurrency of one in the queue.
Did you learn anything about the cost of using AWS?
Yeah. You know, I mean, that's the thing. It was super easy to set up. We have a great repeatable environment for Vagrant Chef. At the end of the day, it is more expensive than I think rolling this stuff ourselves. But from zero to like a decently complex architecture, I haven't used anything else that can do it quicker and easier.
Our billing alarms did go off every single month.
What's great though is we're on the free tier, so for the most part, it's up for $20 a month at this point.
Until we start boosting.
Yeah, different story in 6 months.
One more question.
So I saw 4 big pieces. One was a website, one is the fingerprinting, and then you had video player on the website and video player on iOS. That's the one that jumped out underneath. Which of those was easiest?
Easiest.
Yeah. I would actually say the audio fingerprinting. Surprisingly, we use a library called Deja Vu, which is an open source library for audio fingerprinting. However, I used this audio library previously last winter in a 4 to 6 week research project. And by the end of it, we had determined that we could in fact use it to determine multiple matches between videos. However, it has come a very long way since then. But modifying that library was not as difficult as we anticipated. But coming up with a way to use that information was.
And Brian, you have one last question.
Yeah, so from a kind of a software engineering methodology, I saw your collaboration and how you kind of manage the cards. One thing I'd be interested in is how did you actually do more of the project management? How would you estimate knowing where yours should be, where your, it seems like you had a couple of significant coding sprints based on your graph. I mean, was it kind of work towards the end and just get it done, or did you set milestones and manage towards an estimate complexity?
A project manager probably.
Sure. So as you mentioned before, we use Trello, and we were able to use a tool in tandem with that to generate a Gantt chart, which kind of kept us on track for the project. We were able to set estimated times, or completion times for particular tasks. From a larger view, I want to say our process was largely iterative. So because our calendars scheduled into we had 3 terms to do this essentially. By the end of the fall, we developed a lot of the API. And the second term, we pretty much had the working product. This last term was spent doing a lot of refinements, especially with the documentation that we developed in terms of requirements, design, testing. I think that also helped us set milestones within each 3-month period.
Okay. I got one more question. You guys going to work on this post schools?
We would like to. We're not sure exactly how we're going to work on it yet, but we would like to do something with it for sure. We put a lot of work into it, and hopefully it's not for naught. So.
Great. Thank you, JamJar.